We want to start off by, I'm just going to say one small thing. The objective of our session is to present, a measured peek into really the immense spectrum of ideas and challenges that are associated with achieving an interstellar journey. And we're looking at crewed and robotic, right? So there are immense challenges. And even though there are constraints in the time and what we can do, we just want to give you a little peek that says that there may be some direction, some path forward. But to start off, my co-chair, Karl Aspelund, which I'll tell you more about him later when he speaks, but he wants to do something.
So we have a poor man's cahoots here. This would be appropriate, I think. And so we would like to see a show of hands, please, before we begin. Do you think human interstellar travel will be achievable in, let me see, 100 years, please? Oh, not bad, not bad. I think we've got something here. 200 years. 200 years, about the same. And I think I saw some double dipping too. 500 years. Oh, Harry, we need to talk. And D, never. Never. Lou, come on, Lou. All right, thank you. Never. Okay, thanks very much. Yes. Okay, well, I guess that sets the tone. We seem to be somewhat equally divided between A and B. The people who will look for 500, I'll meet you outside, and never will just pretend it didn't happen. May. What's that? You'll be... We'll talk tonight. Okay.
Sounds great.
Sounds great. All right.
So
I'll let you get on with it.
the way we're going to start with this is I want to just do an introduction to the whole idea of interstellar. And it's going to be fairly top level. Some of the presenters will get in deeper, but I just want to do a little round robin of what's going on. First of all, just some notes on interstellar. In 2011, DARPA, with assistance from NASA Ames, introduced this workshop in January 2011 that looked at human interstellar flight, which was sort of like woo-woo, right? The technical term. Back in those days. So I was really impressed and surprised and delighted with the show of hands. But this workshop happened, then there was an RFP that was let in 2011. It was due 11/11/2011 was the due date, some numerology there. And it was for a very modest seed funding grant to start an organization that could sort of shepherd in and looking through the challenges for human interstellar flight. And it created quite a buzz in the sort of the space community because DARPA gave some validity to something that, before people really just didn't talk about, right? So I want us to know, though, that this was not the first time that the scientific community had sort of seriously sat down to think about and talk about interstellar flight. So if you go back, there was the Daedalus Project. Even the Rand Corporation had a whole program and wrote a white paper on human interstellar flight. When we looked back, we were able to find a paper from Paul Krugman when he was in college talking about interstellar trade. He said, when I talked to him, there was a little bit of like a play on things, but he was serious about it. So we can go and look all the way through. As we go forward, there was a Keck Institute had a workshop on interstellar studies, of which Lou Friedman was part too, and was the impetus for doing it. We looked at Breakthrough Starshot. There's now an interstellar probe that's being put up and around. There are a number of organizations that are looking at interstellar in different ways. And people are writing stories and books about it. In fact, Les Johnson, who does the Interstellar Research Group, was looking at, wrote a book on things. There are lots of things that are out there. I have the privilege, one of the things that came up was Sonny White and the whole work around, can we go faster than the speed of light? So there's a lot out there. And so what we need to do, and what's different about this now, is really that we know more. right? We have more possibilities that we can look at. And I think that that's really the issue, and that's how we got here. And if you start to look at, when you talk about human interstellar flight, or even talking about it, remember in 1901, H.G. Wells wrote First Man on the Moon, and it was less than 70 years later that we were on the moon, and we had no rocketry back then to speak of. So some of these capabilities may be moving faster. I'm just going to tell you a little bit more about this. 100-year Starship, I was very fortunate to lead the team that won the seed funding grant, and it was called An Inclusive, Audacious Journey Transforms Life Here on Earth and Beyond. And our task was not about trying to make sure that we launched a mission in 100 years. It was rather to ensure that the environment that would allow those kinds of audacious, bold things happen existed, as well as to push for the capabilities, because no one organization, no one group, or no one team can do this. And we had a great introduction from Harry Atwater that sort of shows us the range and the scope when you get into the complexity, even when the physics, even when the pieces are there, that you can see them through. And the context of a human interstellar journey, or any journey at all, I think is really put together by, put 3 grains of sand into a vast cathedral, and that cathedral is more filled with sand than space is with stars. It just sort of, we know all this, we can do all the numbers, but just the visceral feel for what's happening. And so if I talk about understanding the interstellar journey, just sort of the challenge is this distance. It's distances that we don't do. It's not Mars. It's completely different than Mars. We've been to Mars 2-3 times. We landed and stuff on, even when I was a little kid. But the distance is different, right? So we're not able to do it in the same jump. So that's the reason why we need different kinds of systems to do things. The time, even if you go 20% the speed of light to our closest star, you're still talking 20 years, 10%, it's a long time. And so we haven't been able to build craft that purposefully do that, particularly if you have humans on board. And then there's autonomy. Because you get to going that fast, it might be kind of difficult to stop to pick up groceries. So you really want to be able to figure out, how is this system going to be autonomous? And once you get there, how you're able to survive. There are lots of pieces in there. And 90% of it, what you're going into is dark. Okay, I'm going to do this right now. Phil Lubin said he had my back. 90% is dark, right? Dark matter, dark energy, basically a factor to adjust things to make the equations work out right. And my high school teacher called it a fudge factor. But basically we don't have all the information we need to do with guidance and a lot of other issues. But that's what's so interesting about it. It's all these hurdles that drive us, right? That makes us think about things from a very different perspective than we had before. And those are the pieces that we have to look at, and that's what's so compelling. Because to me, that dark, it's like going into the future, which we're all going to do whether we want to or not. So I just want to give some of the initiatives and programs. 100-year Starship, love to talk to you about it more, but that's not it. But we do things ranging from trying to look at new disciplines with crucibles where we want to forge and move things forward, excellence in writing books for kids and education, looking at community colleges, because the people who put together these vehicles are not going to be 4-year degree college folks, right? It's going to be a different group. How do you get the public involved? Like Nexus Nairobi, where we had our 10th anniversary celebration, was actually in Nairobi, because we're going to the cradle of humankind, right, with Interstellar. But those are some of the issues, but I wanted to just show you those, as well as issues around how do we connect people. But an Australian Aboriginal proverb is that, traveler, there are no paths. Paths are made by walking. So you actually have to start doing this to actually figure out what's going on. So here, just some smattering of all the kinds of things. And this is not completely inclusive at all, by no shape or form, but all the kinds of things that are part of actually getting to human interstellar journey. The radical leaps. They're disconnected, disjointed. They're not necessarily the things that we know how to do. They're not necessarily small evolutionary takes on it, but they're radical departures. And And so if we think about this a little differently, and I want to place things in context, we can almost divide this up, and this is really a hokey division. So everybody knows that most of these things run across, but from where we are, Earth systems, some of the things that we have to do on Earth before we can do this in our solar system, what are some of the things that must be looked at while you're actually on the journey itself? And arrival, what happens when you arrive? Right? There are lots of things there. And this is where we're going to pick up with our presenters. But so we're going to talk about huge spacecraft and velocity. How do we get out of Earth orbit? Because, if we're stuck in Earth orbit and can't get out except for sending up rockets, and how much of the payload did we burn up as a rocket? We're going to be in trouble. So how do you get up? Long ways. Designing for interstellar, it's not going to be the same thing as designing for a trip here in Earth orbit, or even a trip to Mars, or even a trip to Saturn. It's going to be very different. And we'll talk about some of that from different points of view. Just the overall energy management. Now, I know people, when they talk about energy, we're usually talking about the oomph to get you up off the launch pad. But you need energy during the whole mission, particularly as we have humans involved. That's the reason why we're taking up what Jill Tarter told me was a big squishy bag of water. I'm an MD. I was a chemie too, so I like big squishy bags of water, but that's okay. But that's what makes it so interesting, because of the difficulty of carrying up that big squishy bag of water. But energy management over the entire flight time, we're looking at directed energy and propulsion, another way of sending energy. And I put propulsion when you get there because you have to slow down. You got to stop. Maybe. Or you just keep flying by the whole time. We'll see. And then finally, looking at new disciplines, because all of it, we're going to really spawn off very different disciplines. It's not going to be the same thing that we've already been doing. So we'll have a discussion about that. And then finally, we're going to talk about some of the societal engagement and commitment, which we're calling human in the loop. Because I know sometimes people think human in the loop is just the person, the crew, and the spacecraft. But the humans piece is all throughout this. So we'll have our final talk with human in the loop, and then we'll create our panel. And we're really excited about this. We always say that we believe pursuing an extraordinary tomorrow builds a better world today. And with that, I'd like to introduce